Somewhere over the Pacific Ocean right now, a signal is moving through the atmosphere that almost nobody is talking about. And by the time you finish this video, you will understand why meteorologists are quietly nervous, while the rest of the world assumes September is going to be calm. Everyone expected a peaceful transition into fall this year. The forecasts looked ordinary, the headlines were boring, and most people already mentally checked out of storm season. But something changed in the last few weeks, and if you stick with me for the next few minutes, you are going to see exactly what that something is, and why it matters more than you think. Before we go further, if this is your first time here, welcome to Universe Proof, the place where we take complicated science and turn it into something you can actually understand and use. We are not here to scare you with clickbait weather panic. We are here to show you the real mechanics behind what is happening above your head, so you can see the pattern before it becomes the headline everyone else is reacting to a week too late. So let's start with the calm everyone expected. Back in early summer, long-range models were painting a fairly quiet picture for September. Ocean temperatures looked like they were settling into a familiar rhythm, the jet stream was behaving in a fairly predictable way, and forecasters were leaning toward a mild, unremarkable transition from summer into autumn. That kind of forecast makes headlines boring, and boring headlines don't get attention, so most people never even heard about it. Quiet months rarely trend online, but quiet months are also exactly when patterns can shift the fastest without anyone noticing in time. Here's the first thing you need to understand. Weather does not move in straight lines, it moves in waves. And those waves are controlled by something most people never think about, the jet stream. Picture a river of fast-moving air circling the planet several miles above your head. When that river flows in a smooth, relatively straight line, weather stays predictable, storms move through quickly, and temperatures stay close to normal. But when that river starts to bend, buckle, and loop like a snake, everything changes. Warm air gets pulled north into places it normally would not reach. Cold air gets pulled south, and storm systems that would normally pass through quickly instead stall out for days. Over the last several weeks, that river has started bending in a way that is catching the attention of atmospheric scientists. Instead of a smooth west to east flow, models are showing a deep dip forming, the kind of pattern meteorologists call a trough, sitting in a position that historically has been linked to unusually active and unpredictable September weather. This is not a small wiggle in the data. It is a structural shift in how air is moving around the planet, and structural shifts like this tend to cascade into effects that last for weeks, not days. Now let's talk about the ocean, because the ocean is the engine behind almost everything the atmosphere does. Sea surface temperatures across parts of the Pacific have been running warmer than the models expected just a couple of months ago. Warm ocean water evaporates faster, pumping more moisture into the air above it. That extra moisture becomes fuel. It is the same kind of fuel that powers stronger storms, heavier rainfall events, and more explosive development when the right ingredients come together. When you combine unusually warm ocean fuel with a jet stream that is bending into an unstable shape, you get the conditions for a pattern that behaves very differently from what everyone originally expected. There's another piece of this puzzle that rarely gets mentioned outside of research circles, and that is the influence of the stratosphere, the layer of atmosphere sitting above the one we normally think about. Sudden shifts in stratospheric wind patterns can ripple downward over the following weeks and reshape the behavior of the jet stream far below. Scientists have observed early signs of this kind of disturbance forming, and historically, when this type of stratospheric nudge happens, heading into early fall, it has been associated with more volatile weather swings than usual, larger temperature contrasts across short distances, and storm tracks that refuse to follow the normal seasonal script. So what does all of this actually mean in plain language? It means the smooth, quiet September that everyone was expecting just a couple of months ago is now looking far less certain. Instead of a gradual gentle slide from summer into fall, current signals point toward a more chaotic transition, one with sharper temperature swings, a higher chance of rapidly intensifying storm systems, and weather that seems to change faster than forecasts can keep up with. This is exactly the kind of pattern that catches people off guard, because it does not match the calm narrative that was set months earlier. Think about how forecasting actually works for a second. Long-range outlooks are built on averages, trends, and probabilities calculated from current data. When the underlying data was pointing toward calm conditions back in early summer, that is exactly what forecasters said. But the atmosphere is not a fixed system. It is constantly recalculating itself in real time based on new inputs, warmer water here, a stronger ridge there, an unexpected nudge from the stratosphere above. As those inputs shift, so does the outcome, and that is precisely what has been happening under the surface, while most people were paying attention to something else entirely. This is also why meteorologists tend to get nervous in situations like this one. It is not because they know exactly what is going to happen. Nobody does, not even with the best models on the planet. It is because the ingredients are lining up in a way that increases the odds of extreme outcomes, even if the average outcome still looks somewhat normal on paper. A shifting jet stream combined with abnormally warm ocean fuel is historically one of the more reliable recipes for rapid, unexpected changes, the kind that do not show up clearly until just days before they actually happen. Let's bring this back down to something you can actually picture. Imagine two neighboring regions just a few hundred miles apart. Under a stable, predictable pattern, they would experience roughly similar weather, maybe a few degrees difference, a similar chance of rain. But under the kind of buckling, unstable jet stream pattern we are seeing form right now, those two regions can end up experiencing completely different realities within the same week. One area gets unusually warm and dry conditions, while the other gets hit with a stalled storm system dumping far more rain than normal in a short period of time. That is the signature of an unstable pattern, and it is exactly the kind of signature showing up in current data. It's worth pausing here to appreciate just how interconnected this entire system really is. A shift in stratospheric winds thousands of miles away can influence storm behavior over an entirely different continent weeks later. Warm water, sitting quietly in the middle of an ocean, can end up fueling a storm system that forms nowhere near it. This is the beauty and the challenge of atmospheric science. Everything is connected through pathways that are invisible to us on the ground, yet powerful enough to reshape entire seasons. Understanding these pathways is exactly why channels like Universe Proof exist, to help you see the invisible threads connecting events that seem completely unrelated on the surface. Now, it is important to be clear about something. This does not mean a single guaranteed catastrophic event is locked in and certain to happen. Weather forecasting, even with the most advanced models available today, works in probabilities, not guarantees. What we can say with confidence is that the ingredients currently in place favor a more volatile, less predictable pattern than what was expected just a couple of months ago. The calm scenario is no longer the most likely outcome based on current data, and that shift alone is significant enough that it deserves attention rather than being quietly ignored. If you zoom out and look at the broader picture, this kind of shift is also a reminder of how quickly assumptions about the future can change. 3 months ago, the story was calm and predictable. Today, the story is instability and rapid transition. This is not a flaw in forecasting. It is simply how a dynamic, constantly evolving system behaves. The atmosphere does not care what anyone predicted last season. It responds to the conditions in front of it right now, and those conditions have clearly moved in a different direction than expected. So, where does this leave things heading into the weeks ahead? Expect the unexpected might sound like a cliche, but in this specific case, it is actually the most accurate way to describe the situation. Instead of a smooth, gradual shift into cooler autumn conditions, current signals point toward sharper swings, faster developing systems, and a pattern that keeps forecasters checking updated models more frequently than usual. If you live in an area that tends to be sensitive to shifts like this, it is worth paying a little closer attention to updated forecasts over the coming weeks, rather than relying on outlooks that were built months ago under very different assumptions. What makes this story genuinely fascinating, beyond just the practical impact, is what it reveals about how much we still have to learn about the systems shaping our planet. Every one of these shifts, the jet stream bending into new shapes, the ocean quietly building up extra energy, the stratosphere sending ripples downward, is part of an enormous, deeply interconnected machine that we are still only partially able to predict. The more closely scientists study these connections, the more they realize how sensitive the whole system really is to small changes compounding over time. That sensitivity is exactly why patterns like this deserve real attention instead of being brushed aside as just another forecast update. It is not about fear, it is about understanding. When you understand how a bending jet stream, a warmer than expected ocean, and a shifting stratosphere can combine to completely rewrite a season's expected outcome, you start to see the world a little differently. You start noticing the invisible forces behind the weather on your phone screen instead of just reacting to it after it has already arrived. There is one more layer to this that makes the picture even more interesting, and that is the role of atmospheric rivers, narrow corridors of concentrated moisture that stretch for thousands of miles across the ocean before slamming into land. Under normal conditions, these moisture corridors behave in fairly predictable ways, delivering rain in manageable bursts. But when they form under an unstable jet stream and feed off unusually warm ocean water, they can intensify quickly and deliver an entire season's worth of rainfall in just a matter of days. Watching whether these corridors form and where they aim is one of the clearest early warning signs scientists are tracking right now. It also helps to understand why this particular combination of factors is so rare compared to a typical year. Most years see either a stable jet stream with normal ocean temperatures or some deviation in just one of these systems at a time. What makes this pattern stand out is that multiple systems are shifting together, the jet stream, the ocean, and the stratosphere, all moving away from their expected baseline within a similar window of time. When multiple large-scale systems move out of alignment simultaneously, the resulting weather tends to be far less predictable than when only one factor is behaving unusually, which is exactly why this situation has drawn so much quiet attention from people who study this for a living. Before you go, if this kind of deep dive into the hidden mechanics behind the world around us is something you enjoy, this is exactly what Universe Proof is built for. We break down complex science into something clear, honest, and genuinely interesting, without the panic and without the fluff. If this video helped you understand something new today, drop a comment and let us know what surprised you the most, whether it was the jet stream, the ocean fuel, or the stratosphere connection. Your comments genuinely help this channel grow, and they help us know exactly what to dig into next. And if you found this useful, take 2 seconds and share it with someone who has been assuming this September was going to be a quiet and uneventful one. They are going to want to see this before the pattern fully plays out. Hit that share button, drop your thoughts in the comments below, and if you're not already subscribed to Universe Proof, now is the perfect time. Because patterns like this one do not wait for anyone to catch up, and neither do we.